So tumor in the hydrodynamics black there's only environment, but then we have interaction between tumor cells and together. Tumors can be categorized into three different types, namely immunodesert, immunoexcluded, and inflammatory tumors. Immunodesert means there is a lack of immune response. Immunoexcluded means there is immune response, but T cells cannot penetrate into tumor microenvironment. But in inflammatory tumors, T cells can be able to infiltrate into tumor microenvironment and kill the cancer cell from inside. Our in-house data showed patients having excluded and invested tumors had a less probability of survival compared to patients with inflamed tumors. So we investigated if regulating our ideal cells proteins can tolerate and excluded tumors to more inflamed tumors. And those enzymes or proteins either fatty acid pathway or expressed in tumor. Today, I wanted to introduce a little bit about our study of TGF-beta inhibition to inflame immune-excluded tumors and increase chemotherapy response. So TGF-beta is a multifunctional set of peptides that can regulate tumor progression and immune suppression through inflammatory signaling pathway. Loss of TGF-beta growth inhibition have been associated with malignant conversion and progression in different cancer disease. And TGF-beta1 induced EMT can promote targeted migration of breast cancer cells. So we tested TGF-beta expression in EMT6, which is an immune-excluded breast cancer model. And data showed TGF-beta1 and TGF-beta3 are the non-isoforms expressed in EMT6 double tumor. And then we isolated different types of cells. And you can see immune cells normally express TGF-beta1. Myeloid cells can also express TGF-beta3. Fibroblasts express TGF-beta1, TGF-beta2, and TGF-beta3. Tumor cells normally express TGF-beta3, but also express smaller amounts of TGF-beta1 and TGF-beta2. So our goal is to study how TGF-beta regulates tumor microenvironment in EMT6. And if TGF-beta inhibition can deepen the overall survival benefits for patients with any excluded tumors and reprogramming the tumor microenvironment. We treated tumors with different antibodies, including anti-PD-L1 and the combination of anti-PD-L1 with other different antibodies. And data shows the combination of anti-TGF-beta1 and anti-PD-L1 most effective in reducing tract cell. So this is to the so to better understand the mechanism and the effects of TGF-beta inhibition, we are interested in the changes of genes, proteins, protein crosslinks, and lipid metabolites. So from the sequencing, proteomics, amino acid analysis, and genomics to look for potential opportunities for TGF-beta antibody treatment. Today, I will mainly focus on polymer crosslinks and lipid metabolites. So, what are lipids and why we are interested in looking for lipid biomarkers? Lipids are the diverse group of compounds, including fatty acids, glycolides, lipolipids, cyclohormones, and other complex lipids like lipoproteins. Lipids contribute to cancer biology. For example, lipid synthesis and uptake supports cell membrane biogenesis to drive cancer cell proliferation. And enrichment of additional lipids in lipid rapidly induce oncogenic signaling, and that's also it's like LPA or LPC, essential inflammatory mediators. So let us act as metabolic state specific biomarkers for tumor diagnosis. They also allow further insight into correlation between genomics or proteomics observations and tumor population. Except for lipids, we're also measured collagen and phosphate levels. Collagen is a large family of extracellular matrix proteins that witness repeating sequences formed by glycerol and hydroxyproline. Hydroxyproline is usually 40% of total collagen, so it can be used as a measurement of total collagen levels. And collagen is the major component of tumor development and extracellular matrix. It participates in tumor processes. Cell behavior as the cell communicates with collagen through symbiotic pathways. And one of the symbiotic pathways have beta symbiotic acid. Studies have revealed a positive role of TGF beta, the symbiotic in collagen multiplication. So to study the correlation between tumors and collagens, we selected 4 different types of tumor model: B16 actin, EMT6, 41, PPR3070 to represent melanoma, memory carcinoma, memory gland, and pancreatic carcinoma. We measured tumor volumes and tumor stiffness, and you can see the right line is B16 actin positive, and then is 41 EMT6, PPR3070 slowest. B16 actin has the lowest tumor stiffness. And you can see the slower the tumor, the higher the tumor stiffness. Then collagen and cross-mix levels were measured. Tumor was localized, reduced, and then hydrolyzed in 6-mol HCl at 100 degrees centigrade overnight. And then the supernatant was diluted. Centrifuge injected into mass and the threshold hydroxide content was significantly over the 60 compared to other reports. And hydroxyproline levels increased from B16 F10 to PPR3070, except for EM6, which is slightly higher compared to 41. Biological prosthetics, DHL, material prosthetics, QID, and PPD was significantly lower in some tumor B16 F10 compared to other 3 types of tumors. And strong correlation was observed between hydroxyproline levels and tumor stiffness. And there's also significant correlation to collagen cross-mix levels and tumor stiffness measurements. So this data showed collagen and cross-mix levels can be used as potential markers to predict tumor stiffness. And then EMT6 was used to evaluate collagen cross-mix and lipid constitution changes after TGF-beta inhibition. In this in vivo study, mescaline EMT6 were treated with isotope control antibody, anti-PD-L1, anti-TGF-beta, and a combination of anti-TGF-beta and anti-PD-L1. And then rest were used at D1, D3, and D5, tumor and serum collected at D8 for proteomics, serum lipidomics, collagen cross-mix, and other PD readout analysis. Infiltrating T cells was measured by flow cytometry, and data showed infiltrated T cells increased significantly in the control antibody treated tumors compared to epitope control and anti-PD-L1 treated tumors. And you can see the tumor volume did not change in control group and anti-TGF-beta1 treated group. There's a small amount of tumors, their volume decreased in anti-PD-L1 treated group. But you can see most of tumors, their volume decreased in control. And then you measure the lipid metabolites. So for lipid analysis, tumor homogeneity was extracted by a chloroform, methanol, and water using light iron method. 3 phases formed after centrifuge. The top phase has polar metabolites, and the middle layer is the protein layer, and the bottom layer has nonpolar lipids. So the bottom phase was transferred to a thing like dry and reconstituted in organic solvent for liquid chromatography and spectrometry analysis. We have a global analysis platform that can measure 12 classes of lipids, including phospholipids, PC, and PE. Their metabolites less phospholipids, LPC and LPE. Sphingolipids, sphingomyelin, ceramide, the hydroceramide, hexoceramide, lactoceramide, lactoceramide. This platform can also measure cholesterol ester, triacylglycerol, and diacylglycerol. And each lipid class contains fatty acids with from carbon 14 to carbon 22, and we call it lipid subspecies. So we will talk about 1,000 lipid subspecies were analyzed. Cholesterol and sterol were measured by targeted lipids. And this slide shows the changes of glycerol lipids and glycerol phospholipids under antibody treatment. Phosphatidylcholine and phosphatidylcholine, also called PC and PE, are the major components of cell membrane. They can produce less phospholipids, LPC and LPE, through phospholipids A2. And phospholipids A2 activity increases in inflammatory disease and produce more PC and LPE. And phospholipids are found elevated in many tumors and have been linked to the tumor progression. And our latest data shows LPC species decreased significantly in combo antibody treated tumors compared to the control tumor. And LPE treated alone may not have significant as LPC. So this data may indicate phospholipids A2 activity decreased after combo antibody treatment. EGK alpha converts the acylglycerol to PA. It has been linked to the activation of VEGF alpha, which has been implicated with prognosis in breast cancer. The inhibition of EGK alpha can rapidly impair cancer cell viability. And we did not see a significant decrease of the acylglycerol in antibody-treated tumors. But you can see all the acylglycerol species decreased in combo and anti-TGF-beta treated tumors compared to the control. The proteomics data also shows VEGF alpha activities decreased significantly after combo antibody treatment. Sphingomyelin is produced from cellulite by sphingomyelin synthesis. So the sphingomyelin synthesis can activate TGF-beta pathway. And we found sphingomyelin species treated lower in single antibody treated groups, and sphingomyelin species decreased the significant antibody treated groups. And then the phosphorus analysis also showed significantly decreased oxide 2 and 3 in anti-TGF-beta and combo antibody treated tumors compared to the and our in-house sequencing data also showed cholesterol homeostasis dysregulated in tumors, so we also looked into cholesterol is metabolized. Cholesterol is converted to cholesterol ester and AKT tissue And increased plasma estrogen levels has been reported in gastric cancer. Inhibition of plasma estrogen replication can impair its aggressiveness through limited CD8 T cell effector function. And latest data showed plasma concentration did not change across different groups. You can see plasma estrogen treated in anti-TNF treating tumors, and plasma estrogen business decreases in compared to the actual tumor. Plasma can be oxidized to oxysterol. Oxysterol as cholesterol is a ligand of nuclear liver acid receptor, which can repress some BP signal and inhibit cell degradation. Some cholesterol levels increased in patients after tumor removal. Latest data also show cholesterol concentration in antibody treated tumors compared to the tumor control. At the end, we measure collagen and prostate levels. Those antibody levels decreased significantly in antibody treated groups compared to the control tumor. And this indicated that collagen levels decreased in antibody treatment. All the collagen prostates were significantly lower in antibody treated tumors. And this may imply that tumor stiffness decreased in antibody treatment. Now we also found lux activity decreased significantly in combo antibody treated tumors compared to the acid. So to summarize the study, lipid profile is changed after antibody treatment. The changes on lipids support enhanced proteomics and analysis data. The plasma homeostasis was dysregulated, decreased plasma estrogen was detected in mouse study. Collagen and collagen prostates decreased in antibody treated tumors. And we will continue to validate to see if collagen prostates plasma estrogen their lipids treatment. At the end, I wanted to acknowledge my manager when he said about support. I also wanted to thank all my coworkers and collaborators from the immunology department for this help. Ready to question?